construct two loops such that we can form a compound circuit instead of a single loop. So notice there is the resistance and the rod that is moving to the right with velocity v2 from one loop here, and there is another loop between the resistance or the rod moving with velocity v1. For the analysis, as far as the Faraday's law of induction is concerned, they act independently, and then we use the idea of Kirchhoff's laws to get what is the current induced in the resistance. So let's call this loop 1, this part, and this as loop 2. Considering loop 1, we know that the flux is decreasing because the loop is decreasing its area as the rod moves to the right between the resistance and the rod. Flux area is decreasing, so flux is decreasing. So the induced magnetic field B induced will be along the direction of B. It tries to increase it by creating more magnetic field in the same direction. And that leads to a current. So B induced in the direction of B means going into the boat. So that means the current I in the in loop 1 is clockwise, which is equivalent to having a power. So if we think of loop 1 in this form, so that's your resistance of the rod. So this is loop 1 here. It is going clockwise, so that means the power, so the equivalent power that you will have to connect is in this direction. Let's call that V1, and this could be the current I1 that is introduced. Right? So that's I1 here, and the voltage is as shown. Current also goes clockwise on top. Yeah. What is the effective voltage V1 or the and the associated current I1? We have V1 is equal to the change negative derivative of the flux, which is B times L times X1, which is the length of the wire between the resistance R and the rod, which is moving with velocity v1. Since x1 causes the velocity v1, the change in x with respect to time, so we have minus b l v1. This is velocity v1, so I should make it a little curly, and this is the voltage, which is capital v1. That's equal to us talking about the magnitude of the voltage. That's B is given to be 0.010 Tesla. L, the length, L between the distance between the rails is given to be 12 centimeters. So that's 0.12 meters. And the velocity with which it is pulled is 4 meters per second. And that leads to four. And that's 4.8 millivolt. That's the voltage V1, and what we are looking for is a determine the direction and magnitude of the current in resistance R. So the resistance R will have a current I1 and I2 coming in. It depends on whether we add or subtract. So we will uh, do that in a minute. So let's say this is loop 2. In loop 2, the flux is increasing. If the flux is increasing, the induced magnetic field in the second loop is going to be opposite to the direction of B, which requires that. So that's your resistance R. So we want to effectively put a voltage on the right hand side, but the induced magnetic field is opposite. That means it is coming out of the whiteboard, and that requires the current I to be moving in the or current I2 to be moving in the counterclockwise direction. So I2 is counterclockwise direction, which requires a, if we were to put an effective voltage there, this will be V2. How much is the magnitude of the voltage V2? That's decided by the rate at which the magnetic flux changes there. So that's P times L times X2 now, where X2 is the length of this rails between the resistance R and the rod moving with velocity V2. So it's minus BL V2. Magnitude of this voltage V2 is equal to 0.010. That's the magnetic field length. L is 12 centimeters, which is 0.12 meters. And the velocity with which the rod is being pulled this time is half of the velocity V1. That leads to, if it was 4.8 millivolt, this should come out to be 2.4. 2 into 2. So that's 2.4 millivolt. So there are two. So overall, what we have is we have a battery V1. So effectively, this is what is happening. So we have a battery V1 and a battery V2 connected in this form. So overall, the current will be I1. So since there is a current I1 going in here, 2 going in here, so the total current will be I1 plus I2. So I total would be equal to I1 plus I2. So that's equal to I1 is V1 over R plus V2 over R. The resistance is given to be 5 ohms. So this is 4.8 millivolt divided by 5 ohms plus 2.4 millivolt divided by 5 ohms, which is The numerator adds up. So that's 67.2 divided by 5. So that's 1.4 milliamps. So that's the this again is an effective diagram. It helps to picturize what is going on in the circuit. So effectively, there is a current from the left loop and there is a current induced from the right loop. In this case, they're adding up. If they were moving in the opposite direction, they could be decreasing too. So with this, I stop sharing the screen and stop the recording.